Welcome back to Saxon Math. This is Course 1, Lesson 19, Factors and Prime Numbers. A factor of a number is a whole number that divides the number evenly. So to list the factors of whole numbers, you would start with the number 1, find the number that is given, and then find all the other factors of the number. So listing them in order. So for example, the factors of 12. So we would start with 1, and I like to start with 12. So 1 and 12, and then work my way into the inside. So starting here, and then I know that 2 would go into 12, and 2 times 6 ends up being the two factors that work to make 12, and 3 times 4 makes 12. There's nothing else in the middle of 3 and 4, so those are the factors. A prime number is exactly two different factors, and they would just be one and itself. So for example, 5 is only divisible by 5 and 1. So 5 is considered a prime number. 6 is divisible by 1, 2, 3, 6, and so on. And so 6 is not a prime number because it does not have just simply 1 in itself as the numbers it's divisible by. It also includes 2 and 3, you can see. All right, let's move on. So the factors of a given number are the whole numbers that divide the number without any remainder. So in this, for example, this would be the factors of 6. 2 times 3 is 6, or 1 times 6 is also 6. So you have 1, 2, 3, and 6 are all the factors of 6 that don't have a remainder. If I took 6 divided by 6, I get 1. There's no remainder. 6 times 1 is 6. If I took 6 divided by 2, I'd get 3. If I took 6 divided by 3, I'd get 2. If I took 6 divided by 1, I'd get 6. No remainders in any of those. So example 1, what are the factors of 10? Well, here they are. They're listed, but usually I start with 1, and then I go to 10, and I know that 2 will go into 10 5 times, and 3 doesn't work, so 3 is not it, and 4 does not work, so 4 is not it. That's it. So the factors are 1, 2, 5, and 10. Those are all the factors of 10. So factors of 10. Let's look at another example. How many different whole numbers are factors of 12? So if you look at the factors of 12, you got 1, and then 12 is what we're going to start with. We've looked at this before, but let's look at it again. 2, 6, 3 times 4, and then there's nothing in between that you can multiply with to get to 12 without a remainder. So these are the whole numbers that are factors of 12. There's 1, 2, 3, 4, 5, 6. So this question asks how many numbers are factors of 12, or how many whole numbers. So the answer would be 6 whole numbers would be the factors of 12. There's 6 of them. All right, here's some example 3. The first 4 prime numbers are 2, 3, 5, and 7. What are the next 4 prime numbers? Prime numbers are just numbers that can only be divisible by 1 in themselves. So if we go to just a number chart here, we can see that 8 isn't prime because you can take 8 divided by 2 and get 4. So the factors of 8 would be 1, 2, 4, and 8. The factors of 9 are 1, 3, and 9, so it has to be just 1 in itself. Factors of 10 won't work, and as a matter of fact, you can see that all the factors, anything 10, 20, 30, 40, 50, 60, none of those are going to be prime numbers. Most anything that ends in an 8 is not going to be a prime number. Most anything that ends in a 6 is not going to be a prime number, or a 4. Or if it ends with the 2, unless it is 2 itself. Remember, 2 is only divisible by 1 and 2, so that's why it's a prime number, even though it's an even number, and pretty much every other even number after that is going to be prime, or sorry, composite is the word. So it's a composite number. And then prime numbers are numbers that are only divisible by 1 and itself. So the next 4 prime numbers after 7 would be 11, 13, 17, and 19. And if we went further, you can see 23 is only divisible by 1 and 23. 29 is only divisible by 1 and 29. 31 is only divisible by 1 and 31. So you can see that all these others are composite numbers because they're divisible by 1 in themselves as well as additional whole numbers. Like 21 is divisible by 3, it equals 7. So 21 is a composite number. It is not prime. All right, let's try these. So list the factors of the following numbers. So the factors of 14, starting out with 1 and 14, let me just give it some space. I know that 2 goes into 14 and I'm going to put what I would multiply times 2 to get to 14 over here, 7. 3 does not work. I don't even need to try that. I know it doesn't. 4 does not. 5 does not. 6 does not. And 7's already used. So these are the factors of 14. They are 1, 2, 7, and 14. Letter B, go ahead and do that. So again, you'd start out with 1 and 15. You might want to give yourself some space, and you work through it. Working from number 1, I'm going to count up to number 2. Number 2 does not go into 15 evenly without a remainder. So that does not work. 3 does. I know it 3 times 5 actually. So 3 times 5. 4 is the only other number between 3 and 5, and 4 times nothing will get me to 15 without a remainder. So the factors of this one are 1, 3, 5, and 15. All right, do letter C, the factors of 16. You should have said 1 and 16 to start with, and then you go to 2 wholes, and I know that 2 times 8 equals 16. 3 times nothing will get me to 16. 4 times 4 gets me to 16, so that's it. There's nothing in between 4 and 4. 4 times 4 is 16. So these are the factors of 16. Now do the factors of 17. Factors of 17, again, you want to start so you have some space to work with. 2 won't go into 17, 3 won't, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, nothing will. These are the only 2 factors of 17. You could rewrite it. You could just put them closer together after you realize that. So if 17 is a prime number, you can see. Letter E, go ahead and do that one. Which number in each group is a prime number, and explain how you found your answer. All right, so go ahead and after you've answered that, you should have 23 is the prime number. And 23, you might realize, well, you might have said, well, to find this, I knew that 21's factors, the factors of 21 are 1, 3, 7, and 21. So that means it's not a prime. The factors of 25 would have been 1, 5, and 25, because 5 times 5 is 25. So that means 23 is the only one that's left. If you look at it closely, you know that 1 times 23 is the only thing that will get you to 23 without having a remainder if you're going to divide them. Do letter F. 31, 32, and 33. All right, the prime number in this set would be 31. 32 is an even number. Anything with ending in 2 is going to be divisible by 2, so therefore, because it already has 3 or more factors, it is not prime. Prime numbers can only have 1 in themselves that they're divisible by. 33 is divisible by 11, if you forgot that. It's divisible by 33 as well, and 1, so it's got 3 factors. Do letter G, 43, 44, and 45. You should have found that 43 is the only prime number. In this case, 44 is divisible by 2, so that makes it have at least 3 factors. 45 is divisible by 9 and 5 and 1 and 45 itself, so that's a lot of factors, and it's definitely not prime. Letter H, which number in each group is not a prime number? So we're looking for the one that is not. So letter H, go ahead and do that. So hopefully this jumped right out at you. This is not a prime number because it ends with a 2. And 2 means, if it ends in a 2, it means it's divisible by 2. 42 divided by 2 would actually end up being 21. 21 times 21 makes 42. So you can see 42 is not a prime number. It's a composite number. 41 is only divisible by 1 and 41, and 43 is only divisible by 1 and 43. Do letter I. Okay, doing letter I, you would see that 51 would be the answer because 51 is divisible by more than 1 and itself. It's also divisible by, let's try 3 here. That would go in there that many times. That would be 3. This would be 21. That'd be 17. So 3 times 17. That means 51 is not a prime number. Letter J. 23, 33, and 43. All right, in this one, you should have noticed that 33 is also divisible by 11. So it means it's divisible by more than 1 and 33, which makes it not prime. It's a composite number. Prime numbers can be multiplied to make whole numbers that are not prime. For example, 2 times 2 times 3 equals 12, and 3 times 5 equals 15. Neither 12 nor 15 are prime. Show which prime numbers we multiply to make these products. So if we've got 16, if we were to break that down into, let's use a prime number here. Prime would be 8, 2 times 8. And then let's make this one into another prime number, 2 times 4. And then 4 could be split up into 2 prime numbers, 2 and 2. So we'd have 16 would be the same as 2 times 2 times 2 times 2. And number 18, that'd be the same here. Let me just put this out here. 18, let's break it down into prime numbers, 2 and 9. 9 is not prime because it can be taken times 3, but you have 2 times 9, 3 times 3. So you could have 2, 3, and 3. So 18 would be these numbers, 2 times 3 times 3. All right, thanks for watching. Make sure you guys go ahead and do your written practice 19 in math class during the day. You have 50-minute periods in order to accomplish those 30 problems. This is your homework. You are done. Excellent work.